Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And since we are slowly but surely approaching the summer season, I thought it might be fun to talk about the sea breeze and what actually generates that onshore flow that you feel on the beach in the afternoon in the summer months that cools you off at least a little bit. Sometimes it makes it more humid, but at least it cools the temperature a little bit. So let's get started here, and you may have assumed that we're going to need to talk about some definitions first of all before we get into the actual process. So here we go. There's something called the specific heat, which is the amount of energy needed to raise the temperature of a given mass by 1 degree Celsius. Now, the technical science definition says 1 degree Kelvin, but the magnitude of 1 degree Celsius is the same as the magnitude of 1 degree Kelvin, and I think people are more familiar with Celsius than Kelvin, and so that's why I worded that the way that I did. Now, the greater the mass, the more energy that is required, so the amount of energy needed to raise the temperature of a little pebble by 1 degree Celsius is not nearly as much as the amount of energy required to change the temperature of a big rock or something like that. Now, the specific heat of air is 1,000 joules per kilogram per degree Celsius. Now, you don't need to worry about what a joule is. It's just a unit of energy. Okay, that's all you need to know for our purposes here today. But the specific heat of water is 4,184 joules per kilogram per degree C, which means that for the same amount of mass, it takes 4.184 times as much energy to raise the temperature of water 1 degree C as it does to raise the temperature of the air 1 degree C. So as a result, the warming and the cooling of water lags the warming and cooling of the air significantly. And this is why people that don't like crowds and don't like spending a lot of money go to the beach after Labor Day, because the rates are lower, obviously. But the other thing is that the water temperatures peak in the month of September, even though the land temperatures on average are starting to go down. So again, anything the air does, the water is going to do the same thing, but at a much, much slower pace. So here's a table I made up of the average high temperature at Wilmington during the 12 months of the year and the average water temperature at Wrightsville Beach during all 12 months of the year. And then on the far right, you see the difference between the two. Now, it turns out that you need about, or at least, a 6 degree Fahrenheit difference in temperature between the air and the water to generate a sea breeze circulation in the first place. So you can see that the months of February through August all qualify there in terms of months where a sea breeze would certainly be possible during the late morning and especially the afternoon. Now, if you have a larger scale circulation, like some big storm or a tropical system or whatever, that is generating a strong wind that is parallel to the coast, that can easily disrupt the sea breeze circulation. Okay, so any large scale flow pattern that is well defined and strong is going to dominate a local circulation like this. But during the months of June and especially July and August, generally the large-scale flow is pretty weak, okay? And so these local circulations can play a big role. Out in Chicago, because they're on Lake Michigan, now Lake Michigan's not an ocean, but it's still a huge body of water. In the spring, the water temperature of Lake Michigan can be in the 40s, while inland at O'Hare Airport, like maybe 10, 12 miles inland, the temperature can be 70, okay, on an April day. And so if you live downtown Chicago and the wind's coming in off the water, you're in the 40s, and your neighbors that live out near the airport are 70. So it can really have a big effect on temperature differences from one location to the next. Okay, so here's my poor man's graphical example of the land and the water in the month of July. And you may, if you're new, you probably haven't seen videos that we've done about this. But if you have two surfaces of constant pressure, in other words, the pressure along these two surfaces is the same everywhere, the distance between those two surfaces of constant pressure is proportional to the temperature of the air between them. So the farther apart they are, the warmer the air is, the closer together they are, the colder the air is. So let's say we have a constant pressure surface of 1,000 millibars, one at 960 and one at 920, okay? And the water temperature is 82 over the water, appropriately enough. And the land temperature, once the sun comes up, heats up to 90. And so you have more than that 6 degree difference there. Now, what happens is the distance between those two lowest surfaces of constant pressure has got to increase, okay? So the 960 millibar surface now looks like this. And as a result, at the same elevation, now you have a higher pressure here than you do here, and air flows from high to low pressure. So you end up getting a wind pattern that goes like that. Well, you're then transporting mass from here to here, and if you're not removing mass at that location by an equal amount, you're going to raise the pressure here, so you're going to have convergence, all right? And the air is going to converge, and then it's going to go down, and when it hits the surface of the ocean, it's going to spread out. And the component of that spreading out is what the sea breeze is, okay? And so that's the overall process that generates that onshore flow, and the air above the water is cooler than the air above the land, and so that wind pattern acts like a mini cold front, if you will. And sometimes that mini cold front moves inland, and it can move inland by a significant amount, and then you can generate showers and thunderstorms along that sea breeze front. So you're on the beach and it's perfectly clear, but you look west or north or whatever direction you have to look inland, and you're going to see these big puffy cumulus clouds piling up, and they're getting showers and thunderstorms underneath that. But at the beach, it is perfectly sunny. So on average, during the summertime, the beaches tend to be sunnier than the areas farther inland. Now, at night, exactly the opposite happens. And every month of the year, the land gets to be, on average, colder, significantly colder than the water. And so then you set up exactly the opposite, which is a land breeze circulation. And so the air actually blows from the land toward the sea. Now again, if you have a larger scale pattern that is dominating this, then you won't get this effect. But during the summertime, it is very, very possible to actually reverse that circulation and have a land breeze during the overnight period, especially late at night when you're close to the lowest temperature for the day. All right, that is bonus weather video number 1 for this week. I hope you found that interesting and educational. The next one coming up on Wednesday. Next daily update, of course, coming up later this afternoon. So you all take care, folks. We'll talk to you soon. See you later.